Hello and a warm welcome to my poster presentation. My name is Johanna Zikulnik and I am a junior scientist at Silicon Austria Labs in Villach, located in the south of Austria. The poster I present to you focuses on the characterization of highly stretchable screen-printed liquid metal pressure sensors. In biomedical and soft robotics applications, flexible, wearable, and highly stretchable sensor arrays for the measurement of forces and shapes are required. As for today, such printed sensors commonly consist of rigid conductive materials, such as carbon nanotubes or silver nanowires on elastomer substrates. This often leads to a large hysteresis and an increased response time due to friction between the printed layer and the substrate. Furthermore, rigid printed layers are frequently physically damaged during stretching. These issues can be addressed by replacing the rigid printed layers with liquid conductors. As part of this work, we manufactured 3 differently designed pressure sensors using EcoFlex as molded bottom, intermediate, and top layer, and Galinstan as liquid conductor. For the sensor characterization, the temperature dependency of the resistance was measured in a range between minus 20 degrees and 80 degrees Celsius. The sensor sensitivities towards wet conditions, which means the changes in capacitance, were studied by wetting the active sensor area and comparing it to the capacitance in the dry state, as illustrated here in those 2 pictures. The sensitivities towards compressive forces were studied by pressing a digital tensile force device with a flat plunger onto the active sensor area while measuring the capacitance. This intends to simulate the pressure applied with a fingertip. The resistivities of the sensors are nearly linearly dependent on the changes in temperature as expected, and this is illustrated here. Considering the sensitivity, the results show that the sensors are differently sensitive depending on the individual design and measurement configuration, as illustrated here. Some sensors are more sensitive to wetting, while other sensors are more sensitive to pressure. As a conclusion, we can say that the sensor design must be carefully considered depending on the individual application, but Galinstan has proven to be a promising candidate for future highly stretchable, flexible electronics applications, such as electronic skin and artificial nervous systems. Thank you very much for your attention.